So yesterday we spoke about frequency table and histogram, and we said that when you have continuous or numeric, right? Numeric variable. So this is the example of one population or one variable. Okay, and numeric. Of course, the type of data was numeric. So you create histogram. There is another metric that another visualization that you can create or numeric variable. Okay, that is called as box plot. Okay, now what is a box plot? So you arrange you arrange all the numbers in increasing order. So let's say I have 11, 13, 15, 17. Okay. So let's say these are the number, right? And you put them in the increasing order. They will come in. I mean, it will happen in. I mean, uh, okay. Remember, we to find median, we arrange the values in increasing order. Similarly, for a box plot, we need to put it in increasing order because here also we need to find median. Okay. So, so did we do box plot before? No, right? Somehow I'm getting that we did. I don't know. It's your batch or somebody else might have done. Okay. So this is your lowest value, correct? This is your highest value, right? And let's assume, okay, this is your median. Okay. This is your median. Now, median will divide data set equally into two halves. So number of elements on this side will be same as number of elements on this side. Correct? Now, what it says is you find a median on this side also. Find a median in this second half also. Okay? So in first case, you treat entire thing as one data and you find median. Second case, you only take this much as data, okay, and find median. And then, you take this much as data and find median. So now you have divided data into 4 quarters, we call it. Median will divide into 2 halves. Now we created 4 quarters. So this is one set. This is another set, second, third, and fourth. These are called as quartile. Okay, the minimum value is called as quartile 0. Okay, quartile 0 or minimum value. This is called as quartile 1. Okay, quartile 1, which is like 25% of the data. Then this is called as quartile 2. Quartile 2 or 50% of the data or your median. Okay, this is called as Q3, quartile 3. Quartile 3 or 75% of the data. Then this is your quartile 4, 100% of the data, right? Or your maximum value. Okay. So we use quartile to divide the entire data set into 4 quarters. You guys must have heard of percentile, isn't it? Percentile is also, also belongs to same family. It's also part of same family, median and quartile family. What it does is it divides the entire data into 100 parts. Okay. So if you have in total 10,000 records, let's say, you have 10,000 records. So you divide 10,000 into 100 parts. So let's say I have 10,000 rows or 10,000 records. We're talking about numeric variable, right? So that means each block will have how many? 100,000, 10,000, right? So each will have 100 values, isn't it? So 100 values together is called 1 percentile. Then you have 100, 1 to 200. This becomes second percentile. Third percentile will be 200, 1 to 300 values. Number of values, okay? We don't worry about the value itself. For us, count matters. When you talk about percentile, quartile, median, it is just the count, not the actual value. First 500 values. Doesn't matter. It could be your 0 to 1. It could be 0 to 1 together is 100 values. They are like 0, 0, 0, 0, 0, 0, 95 zeros and 5 ones. So your values will be 0 to 1 as 100 values. Then you have maybe few more, 4 ones, and then you have 2s and 3s and 4 and 5 and 6 and 7 up to like 200 occurrences. So here your for 0 to 1, you have only 0 to 1 here, but here you might have 1 to 50. Okay, because we're talking about the count, right? So this is the, okay, so this is what we call it as, okay, percentile. Then you have 99 percentile. 99 percentile means how many values will be here? 100 less than 10,000, correct? 100 less than 10,000. So you will have like 9,900, correct? 9,900. Now, if you add 100 to this, this becomes your 10,000, right? So this is your 100 percentile, which is 10,000, right? So when somebody says that my rank is 100 percentile, okay, 100 percentile means maximum, your rank 1. Okay, now if I tell you my rank is 99 percentile, okay, I've got in CAT exam, in GMAT and all those things, they all talk about in terms of percentile, isn't it? So if somebody says I'm 99 percentile, what does it mean? That means that person is in top 99 percentage of the total people that appeared. If the number of people appeared is 100, 99 percentile means you are rank number 2. So if 10,000 people appeared, then your rank is somewhere between 9900 to 10,000, somewhere between that. Okay, exactly 99 means it is, your rank will be 100, 100th rank. Okay, so this is how you create percentile. Okay, then you have decile. Decile is for tens. So the percentile will divide the data set into 100 parts. Quartile will divide data set into 4 parts. Median will divide the data set into 2 parts. Decile will divide data into 10 parts. Okay, and same concept. Okay, so we are now at, we're talking about box plot. So box plot, we need to know what is quartile. And now what happens is, box plot is represented as box. Okay, now I'll go to paint and then I'll talk about it. Wait. So, so you can have vertical box plot or horizontal box plot. Horizontal means your values will be on x-axis. Vertical means your values will be on y-axis. So you'll have, y-axis and x-axis. Here also you have y-axis and you have x-axis. So if the values that you're plotting is on x-axis, that is your horizontal plot, box plot. If your values are on y-axis, then you have a standing or vertical box plot. So box plot will have a rectangle box and it will have a handle here. Okay, handle like this. Okay, you can have a handle like this, handle like this. Okay, so it is rectangle box and two handles. Okay, and you'll have something in between here. Okay, this is how your box plot look like. So this is your Q0. Q0 or the minimum value in the data set. This is your Q1. This is your median, Q2. Q2 or median. This is your Q3. And this is your Q4. Q0, Q1, Q2, Q3, Q4. Similarly, Q0, Q1, Q2, Q3, Q4. Okay. Sometimes you will see box plot with some dots here beyond the handle. Okay, beyond the handle. It will dots will not be within this data. Dots, if it is there, it could be one, two, or many, will be outside this handle. So this dot indicates outliers. So box plot is the only plot visualization, okay, only visualization or only plot which will also identify outliers in your data set. No other values will identify outliers. Okay, it will include outliers in the analysis. You have to manually remove it. But box plot is the only plot which will automatically identify outliers for you. So what we see that, okay, this is not the lowest in this case. This is the lowest value. But these values do not fit into the scheme of things. Okay, they are, so if most of values are between 10 to 100, suddenly you see a 5,000 value. This will be treated as outliers. And when we talk about normal distribution, we'll talk about how it identifies exactly. But for now, just understand what outliers means, right? Outliers means they don't go along with the numbers, right? It could be much higher than the most of the values. Okay, you might have, let's say, minus 50. Most of the values are between 10 to 100. Minus 50 would become an outlier, or even minus 20 would become an outlier. Here you have 100, but suddenly you see 5,000 or 500 or 900. They will be treated as outliers. Okay, so box plot will identify the outliers and it will mark on it. So let's talk about some examples here. Okay, because we need to identify some examples. Okay, so that you understand how box plot or how box plot work or what is the significance of box plot in data analysis. So I'm saying box plot examples. Okay, and I'll put on images. So see, this is one such box plot. So it says age by group. So see, these dots are not outliers. These dots you see, they are not outliers. These dots actually indicates the distribution of the data. Data may not be equally distributed between a starting and ending value. So if you see here, okay, if you see here, it looks like there are more number of people in B. See, box plot will only tell you percentage. That between this handle to this starting of the box, this is the range of first 25% of the data. Total data is 100, then first 25% will be 25. If number of data is 10,000, then first 20% will be 2,500, correct? So this shows you the percentage. But how do you know how many values are there? So you see here, it says that probably B has the maximum number of people and B almost equally distributed. least number of people falls in group D. So when you create this age by group, and see, this is a vertical. Okay, so data is on y y axis. Okay, so your handle, handle, lower handle is the lowest value. Now I'm going to give you maybe 30 seconds to watch this, okay, and try to, try to understand what it means and then explain. What do you think this data is talking about? I want you to talk about this graph, whatever you understand.
So looks like the age group from 20 to 80 has been considered here.
Okay.
And most of the people fall under maybe 30 to 60.
No, okay. Now see here you have 4 different groups.
Okay.
Okay. So we have seen, like, in our discussion one, how to plot a box plot, right? But here you have 4 different groups. So it's a way of comparing the values in each of the groups. So question is, how is C different than A? How is D different than C or B or A?
So the younger group is in C,
Mm-hmm.
and then in D there are a wide number of people age,
Perfect. Perfect.
and then
So yes.
yeah, A and B are very similar with around 60, 20 to 60.
So A and B are not very similar. Okay. But see, you have values at maybe 10 also, right? So definitely
Oh,
we have
okay.
values beyond 20 and maybe beyond 80 also, right? Here. Okay, but apart from that, what you said is right. If you look at C, okay, C has mostly the younger lot. Now, if you look at the minimum age, which group has the minimum age? A.
C. C
A.
should have.
Minimum
Oh,
age,
okay.
the lowest, right? Where you have handle lowest.
Okay.
Okay.
Oh, okay. Okay.
Probably after that comes C, right? But if you look at the size of this handle, shorter handle means more values are within that range, right? So
Okay.
even though A has the youngest member, but definitely C has the most of the young members.
Hmm.
Okay. And how do you know? See the median value. Okay. This may be mean. Okay. Dotted line may be mean. So median value, if you see, it is about 30. That means 50% of people are under age group 30 in C group. Maybe this could be, let's say, COVID treatment. People were given different treatment. A group was given different treatment, B different. Because see, when you don't know how to treat a patient, right? Something new has come. You want to do trial. That's why doctor's job is called practice. They have to keep on practicing on you. That's why no two doctor will give you same medicine.
Yeah.
Okay. Because they are still practicing. Okay, if I give this medicine, then what happens? That's what doctor will say. Okay, come to me after 2 days. Why? Because
We are the subject, right?
medicine is working on you or not. Exactly.
Yeah.
And if it doesn't work, it says, okay, I will change the medicine. Now you try a different one. Right. So that's why doctor's job is practice. Okay. And it means practice. So, okay. So what we are trying to do here, okay, we are trying to have 4 different groups, and we're talking about the age group, right? Here we are talking from age perspective. So your C group has a lot of younger folks. And here you see B has very few people in quartile 1, quartile 3 and quartile 1, but most of them, okay, the spread is much higher here. Okay. So yeah, lower the size of the box, that means values are more concentrated. Longer the box, that means values are more scattered, isn't it? So if you see between first half values, range is like let's say 15 to 30. So the spread of lower value to half is 15 years to 30 years. But look at the second half, from 30 years to 70 years. Right? The second half has 30 years to 70 years spread. Okay. Now let's do this one more and we will end. We'll move to some other topic. So now what do you understand from this? Experiment number. Okay. Make your own assumptions. Okay. So see here first. Your third and first, they have outliers. See, box plot has identified outliers. Okay. So your group A has outliers on the lower side, and group C has outliers both on the lower side as well as higher side. Now you see here, speed of light, okay, measured by 4 different experiments. Now you tell me, which experiment is giving you more consistent result? Experiment number 3.
Oh, 3. Okay.
Because the values that you see here are less spread. It's like now there's no handle between Q1. There's no handle means what? There are a lot of values between
Not scattered.
850. So let's say if you're talking about 100 values, okay, 25 values have same number, 800, 850, 850, 850, 850. More consistent. So consistent that your Q0 and Q1 is overlapping. That's why it doesn't have handle because handle and the box are overlapping on each other. Okay. But if I have to ask you, which is more accurate? The red line is true speed. Okay. Experiment number 3, though seems to be more consistent, but all the values, and we generally ignore outliers, right? All the values, if you see, are above true speed. So if I have to believe an experiment, which experiment I am doing correct, which one I'll believe? Most
4,
probably 4, yeah. Okay. Because if you see, not 50%, but maybe 40% values are below that, and and few values are above that. So that red line is closer towards your median. Now, experiment number 5 also has line closer to median, but most of the values are above 800, right? Okay, so that's why, okay, we would go with experiment number 4. Mostly experiment number 4 is the one who is giving us probably more accurate or closer to true true speed of light. Okay. Now we will move back to our Excel. So that's what box plot talks about. So when you talk about one numeric variable, you will end up drawing histogram, you end up drawing box plot, depending upon the business requirement, what you want to know. But these two are important graph for one numeric variable. When you have two numeric variable, so okay, telephone bills an example, right? Or we discussed about age group, age, or light, speed of light given by the experiment. These are the values, right? Now, if you talk about two different groups, two different numeric groups, what could be the example? Let's say temperature. Okay, we'll open a new tab here. Let's say temperature average temperature of the day versus ice cream sales in dollars, let's say. Okay, so you have temperature on one column and ice cream sales on one column. Let's say if the temperature was recorded at 15 degrees Celsius. We'll talk about degrees Celsius. Ice cream sale for the day was 3,200. Then temperature went to 25 degree. Sales went to 7,600. Then temperature was, let's say, 18 degree. Temperature sales for the day was 5,000. Right? It went to 39 degree. It went to 11,200. It went to 38 degree. 38 degree, it went to, let's say, 12,000. Then it went to 35 degree. It was like 10,000. Okay, so I can see the temperature, I can see the ice cream sales. I want to understand, is there a relationship between temperature and ice cream sales? Can we say that there is some relationship between ice cream and temperature? Can we predict ice cream sales if I know temperature? Can I predict temperature if I know ice cream sales? Okay. So in that case, we draw what is called a scatter plot. Okay. So we draw scatter plot. Let's say graph here. And okay, now these are line graph. Okay. What I want is I want wait. This one. This is actually this thing. This is scatter plot. Okay. So see this. Sorry. So what it has done, Excel. Sorry, guys.
Bless you.
Thank you. On x-axis, we have temperature. 0, 5, 10, 15, 20, so on. Because maximum value was 39, it went up to 45 degree. On y-axis, you have ice cream sales. 0, 2,000, 4,000. Because maximum was 12,000, it went up to 14,000. Each of these dots, okay, represents two values, one on x and one on y. So 15 degree and 32,000, 3,200. See that? So this represents 15 degrees Celsius on temperature and 3,200, somewhere between 4,000 and 2,000. So if you point your cursor, you'll see that. This is again. Now, when you draw the scatter, this is called scatter plot. Okay, scatter plot or XY plot also we call it. Okay, you have x-axis and y-axis, and each point is representing value on x-axis and on y-axis. Now, do you see any trend here? Does this graph tell you something?
Yeah, the more the temperature, the people are taking or buying more ice creams.
Correct. Okay. So correct. Anything else? So yes. Okay. First thing is, do we see any relationship? Answer is yes. Okay. As you increase x, as you increase the value on the x-axis, y value also increases. We say they are directly proportional. Or there are a couple of words. First, are they correlated or not? Answer is yes, they are correlated. And there's a way to calculate correlation value. We'll see. We'll talk about it in some time. Correlated means X and Y has a relationship that you can see. Okay? There is some kind of relationship between X and Y. What is that relationship? So in this case, if X increases, Y also increases. So we say positive correlation. Okay? Positively correlated. Okay, I'll put this here. If I draw another graph where you talk about number of hours you spend on Facebook and marks that you get, let's say, and marks you get in the exam, right? If you spend more number of hours, you get less marks, right? So if you reduce 9, 8, 7, 6, okay, your marks will also increase. 60, 70, 75, 80, right? Now, if I take this and if I draw our XY axis, so you see here, in this case also, we can see correlation. They are correlated, okay? In this case also, they are correlated. So yes, they are correlated. They are negatively correlated. If X increases, Y decreases. If X decreases, Y increases. They go in opposite direction, right? So here Y is decreasing, but X is increasing. Y is decreasing from 80, 70, 60, right? And your X is increasing 6, 7, 8, 9, 10. So this is negatively correlated. And this is positive. As X increases, Y also increases. So we say they are positively correlated. So you have positively, negatively. Then you have one more thing here called strong or weak. If you draw a line, okay, if you draw a line which will, okay, let's say we'll call trend line. Okay, trend line can be linear, exponential, logarithmic, we'll take linear. Okay, if you draw this trend line, you see these dots are closer to this trend line, correct? In this case also, they will be closer to trend line. Linear only we will take here, right? So when these dots are closer to strong line, this trend line, we say strong. They are strong positive correlated. So temperature and ice cream sales are strong positive correlated. Here also they are closer to the line. So we say they are strong negatively correlated. And correlation value changes from 0 to -1 or +1. Okay. Now, if it is positively correlated, it will go from 0 to 1. Okay. If you talk about, in this case, it is going to be 0 to -1. Because this is negative direction, right? So value will range from 0 to -1. And positive, right? So value will range from 0 to 1. So correlation value has two things. One, the direction, positive or negative, plus or minus, and other is the value. If the values are all like in this straight line, okay? Now, for example, if you talk about number of hours you do swimming versus, let's say, marks that you get. You swimming for 10 hours or 15 hours. You swim for 20 hours. You swim for 30 hours, 40 hours. Okay. Now, how do you get this data? I'm just taking the example I'm talking about. See, you have an hypothesis, right? That we are saying negative first, but this has to support with data, right? So what you do is, in this case, you go to a ice cream shop. Okay, not one, multiple ice cream shop. And you ask them how many sales you made on each day. This guy will say 4,000, this guy will say 3,000, So you'll have 10 different people selling on each day. Now you go to weather.com and see the temperature for that day. So temperature for that day was 15,000 and average of 10 ice cream shop sale was 3,200. Then okay, for 15,000, temperature was 15,000, the
15
sale
degree.
was about 3,200. In this case, you go and talk to previous student who has already appeared for the exam. You ask them, how much marks did you get? He'll say, I got 50% marks. How many hours did you spend on Facebook? This guy will say 10 hours I spend on every week, let's suppose. Then you go and ask second guy, how much marks did you get? 60%. How many hours did you spend? 9 hours. So this is how you get marks here. Then here, same thing, same like this. Okay, you go and talk to first student. He's how many hours did you do swimming? I did 10 hours per week. How many marks did you get? I got 65. Second student, I got 69, 59, 69. Okay, this fellow will say 59. This fellow will say 68. Now, when you draw this graph, you see dots. Can you find any trend here? No. And if I try to get a trend line, okay, so see, it looks like a slightly positive. The line is going up, slightly positive. This is like very, very, very weak, almost equal to 0. Okay. But when you do the calculation, if you calculate the correlation, it will not be 0. It will be 0.1 or 0.2. Okay. But let's say this one is high, right? Second value. No, which is this? 20. If I make this as 64, okay, it is still high. I'll make this also as 65. Now, in this case, also slightly, it will be like 0.05. If I reduce 40 wala also to, let's say, 61. Okay, no. 61 is too. It became negative, but it will be like minus 0.0001 correlation. If I make it 64.5. I'm just trying to show. Now you see, in this case, if you find correlation, it will be almost 0. And we can actually do it and see here. So in Excel, you have a Correl formula. CORREL, Correl. So array 1, I'll select this one. And array 2, you have this one. If you do it, you see 0.003, almost, almost like 0, right? If I make it 64.2, it becomes slightly negative here, right? 2.8, right? So, I mean, yeah, you can see it. But if you calculate here, Correl, you take array 1 and you take array 2. See, 0.98, very, very strong. Almost equal to -1, but negative, going in minus direction. It will be less than 98, okay? It will be 0.9796. So you say equal to Correl. And you take first array and you take second array. Now you perform Correl. You see 0.98, 988. Okay, this is stronger than this. Okay. So see, this is very, very strong. Not only strong, very, very strong, right? Almost equal to 1. So generally what we do is, if the correlation value is less than 0.05, not 0.5, 0.5, okay? We say no correlation. No correlation. Correlation, I mean, see, you won't get perfect zero anywhere. Okay? Getting perfect zero is when you have exact same values. If everybody gets 65, 65, 65, 65, 65, okay, well, then it will be zero. It's divided by zero is infinity, right? So, in that case only it will be zero. But it's not typically it's not possible, right? It become 0.78. Yeah, I mean, it became 0.7. You see, because everything is 0.6 and one small change, it made it big change. So yeah, so 64, 65, 64, 65, and 64.5. Okay, whatever, right? So, okay. So it's not possible to be perfect zero, right? It's not perfect. You can't have perfect zero. So what we say is still, see it is less than 0.5, isn't it? So we'll say no correlation. So this is general understanding. If value is less than 0.05, we say no correlation. 0.5 to 0.75, we say weak correlation. And 0.75 to 0.08. Okay, 0.8 or 0.85. Okay, we'll call this as weak and we will call this as very weak. More than 0.85 only, we say strong correlation. Okay, so this is when you have two values. And this trend line is like a prediction line. You can actually predict. So that means if the temperature on that day is 30°, then how much sales can you expect? 30° means sale would be about 8,200 or 100 or maybe 200. So if the temperature for that day is expected to be 30°, you can predict that, oh, today then the average sale of these 10 shopkeepers will be about 8,200. And that's the foundation for regression algorithm, which we will do sometime later. This is the foundation. This is what a regression algorithm actually does. But here we're talking about two numeric variables. So when you have two numeric variables, we create scatter plots. Scatter plots will tell us the relationship. Is it positive, negative, weak, or strong? Okay. And this is how it works. Any questions so far? Now, what happens when you have categorical value? So if you have one categorical value, okay, then simple bar graph is good enough. So if you have male, male, gender, right? Male, male, female, female, male, male, okay? Then what we do, we count, we say, okay, male equal to 67 and female equal to 137. So we have 67 female, 67 male and 137 female in the group. Okay. Then you will say, okay, let's create this bar graph. This bar graph is enough to handle one value of category value. So this gives you percentage, right? Or you can create pie chart. Right? That okay, in terms of percentages, these are the things. Now, if you have one categorical and one categorical and one numeric. So let's say you have gender versus age, right? So here you will have gender, right? And here you have age group, okay? So I'm going to say rand ran between. Okay, ran between age group, let's say 10, 100. Okay, so let's say you have age group and the age, gender and age. So now what can I do here? What graph do you think we can draw? To understand. Okay, see, why are I plotting graph? I told you, right? To understand, right? Yesterday we discussed to understand the purpose of doing okay visualization. So first it should tell you a story. Second, you should be able to take a action on it, right? So how do you visualize? How do you what do you understand if you have gender and age like this? One categorical and one numeric. Box plot. You draw one box plot for female and one box plot for male. Right? The example that we saw, multiple box plots, right, is because of this. You have gender versus age. So you create two box plot. One box plot, you take only the data from male and create a box plot. One data you take only from female and create box plot. And then you compare. Okay, so female is supposed to be older in this group, right? Possible. So the data will tell you. Yes? Okay, so you can create two different box plots. One for, so in this case, if you have, if you had north, south, east, west. So north, south, east, west, 4. So you'll end up getting 4 different box plots. You can compare how people in north is doing versus south versus east versus west. Okay, so that's a good plot to do. You can also do, okay, histogram, but you have to create again 2 histogram, one for male and one for female. Okay, so that's how you will deal when you have one numeric and one categorical. Have we covered everything or anything else is pending? Guys, have you slept?
Hello.
No,
Yes.
yeah,
So did we cover everything, all possible combinations, or anything is left?
I think it's
We're not
covered.
getting into 3 dimension, okay? I told right. Visualization,
Yeah.
2-dimensional is best, right? So we'll stick with 2 population. Did we cover everything?
I think so.
No. We have covered 1 categorical, 1 numeric. We have covered 2 numeric, 1 categorical, 1 numeric. We have not covered 2 categorical. Yes or no? You might have data where you want to compare gender versus region, let's say. So you have gender and you have region. So let's say here you have male, female, male, female. And region you have north, south, south, east, west, west, east, north. You might want to compare region versus gender. Then what can we do? Okay.
Box, is it? I
Yes,
don't know.
you're right. Okay. So we draw a box. That box is called as consistency table. So on one side, I can say male, female. And this side I can say north, south, east, and west. Okay. And what you do here? Okay, let's first do this. Yeah. I want outline to be thick and inner to be little lighter. Okay, so now you count. Okay, so for north, how many male? How many male belongs to north? So north is 1 male, 2 male, right? So 2 male and 1 female. Okay. Then for south, 1 male, 1 female, 1 male, 1 female. So 2, 2. Okay, similarly, you'll do for east and west. This is called as contingency table. Now, once you have this contingency table, then you can do whatever you want to. You can plot a box plot, graph, whatever you want to do, you can do it. I want to compare only male and North Indian. What generally this graph will tell you, let's say if you have 2, 1, 2, 2, 3, 2, okay, and let's say 4, 5. Let's say we get graph like this, suppose. Then what do you understand? You understand that, okay, this data is more dominated by people from West. Now, let's say this could be your table for high income salaries, right? Of course, you'll have other columns here, right? So when you have like this, if this data is for high income, like, high salaries people, then you know that, okay, West, people generally in the West have more income than, let's say, North. Okay, that's one thing that you can compare. Second thing versus male and female, you'll say that no, male and female, there is no sharp difference between their income. So it looks like male and female have almost similar income in all the regions. Between North, within the region, West has more wealthy people, right? That's why you see count is twice of North and South here, right? But overall, between male and female, they are earning equal. That's what it tells you. Now, let's say if you have 20 from North and only maybe, let's say 4 from, 20 North male and female 4. Then you'll say that, okay, most people, okay, in the North are male who are wealthy. Female are not that wealthy. Right? So this is how you will be able to interpret your answer from this contingency table. Here you will draw the total. So here you will put, that's why extra. So this is how contingency table will look like. Okay, so you will say 24 here, and here you will say sum of and this will be total. So we have total 42 values, 24 from North. Now in this case, North are dominating, but it's North male who is dominating, right? So this is how you will interpret the data when you have two categorical data. Now we have completed all, right? So with this in mind, you can always, when you have any analysis to be done, keep this in mind. Okay, you can analyze any data now. Try not to include 3 columns, but when you include 3 columns, third is mostly going to be your it's going to be your what do you say, common column. For example, let's say I include year. Okay, so year, this is 2022, 2022, 2022, 2022, and then 2023, 2023. So in that case, what you do, you compare only for 2022, and then you compare for 2023. Okay, then you can see, okay, with respect to 2022, this is what I see, but in 23, this was the different stuff. So you'll end up getting 2 different contingency table. One for 22 data, one for 2023 data. Same thing it happens here. Okay. If it happens here, then what do we say? Oh, 2022, females were leading. Let's say you talk about medals, Olympic medals owned by Indians. You can compare, up to 1990s, this was the case. After 1990s, this is the reverse trend. Most of the medals owned before 1970 was male. You're comparing male and female and number of medals, but you're comparing with respect to time, third parameter. So this graph will be based on, you can have stacked bar chart or you can have multiple bar graphs. Then you'll say, okay, until 1970, males were dominating in terms of medal, but after 1970, females are dominating. They have got more medals. Things like that. So you will have that third parameter will be something, the base foundation on which you are comparing. Right? But you'll have two metrics that you want to compare at any given point of time. You can do 4, 5, 6, but then it becomes that much complex. Isn't it? We don't go beyond that. Okay, so we'll stop here for today. Shall we? Or you want to continue for some more time?
I'm good. If you want to continue, I'm good
Okay.
as well. If you want to stop, I think you should take care.